3. Alright. So, Assalamualaikum. Bismillahirrahmanirrahim. So, in this video, I will share to you how to calculate electric charge. Alright. So, first and foremost, I will refresh to you what is the electric charge equation that you have to remember. So, Q equals to I times T. So Q is charge, I is current, T is time. So the unit for charge is coulomb or C. The unit for current is ampere or A. And the unit for time is, of course, second. Alright, so first question. So, how many coulombs of charge will pass through a light bulb when a current of 5 ampere is maintained for 1 minute? Okay, so first we can come out with all the information from the question. So for first one, the information number 1, how many coulomb of charge? So from here, we want to find Q equals to what? Alright, so next, the current is 5 ampere. So I equals to 5 ampere for 1 minute. So T equals to 1 minute. Susah nak. And T is 1 minute. So from here we know that the unit for time is second. So you have to convert minute to second. So 1 minute equals to 60 seconds. So we use equation Q equals to IT. So Q equals to I times T. So I here is 5 times T 60. So 5 times 60 is 300. Okay, so unit for Q is coulomb. Alright, so that's all for question number 1. So next, we go to question number 2. Alright, so how many electrons, alright, so it is twist here, flow through a light bulb when the current of 5 microampere is maintained for 2 minutes. Alright, so you may pause this video to try it out first before I explain the answer. Okay, so first we come out with all the information given from the question. So the question asks you how many electrons flow. Alright, so which means we wanted to calculate for the number of electron. Alright, so through a light bulb when the current of 5 microampere is maintained. So I is equal to 5 microampere. So micro here is the multiplier for 5 times 10 to the power of negative 6 ampere. Alright, so maintain for 2 minutes. So T equals to 2 minutes in seconds. It is 120 seconds. Alright, so you have to remember the number of electron here. Alright, so 1 electron is equivalent to 1.602 times 10 to the power of negative 19 coulomb. Alright, so for this constant I already discussed in class, so you may refresh from the previous lesson. Alright, so so from here we can conclude that so electron has relationship with charge. So here from the question we have I and T. So we can use Q equals to IT to find charge first, and then we convert it to electron. Alright, so let me rub it first so that I have space to do calculations. Alright, so Q equals to IT. Here, remember, we want to find the charge first and then convert to number of electron. Alright, so I, we have 5 times 10 to the power of negative 6 times 2 minutes 120 seconds. Alright, so here how we push the calculator. Alright, so 5 exponential negative 6 times 120. So we get 6 times 10 to the power of negative 4. So unit for charge is coulomb. Okay, so now we get the charge for that flow inside the throughout the light bulb. Alright, so now we want to convert. Now the question asks us how many electron flow. So here we know that 1 electron equivalent to 1.602 times 10 to the power of negative 19 coulomb. So we can times here 1 electron over 1.602 times 10 to the power of negative 19 coulomb. Alright, so why we put 1.602 times 10 to the power of negative 19 coulomb at the denominator? Because we want to cancel out the unit here. So we want electron. So when we cancel C, cancel to C. So what left here is number of electron. Okay, so let me rub this first. Okay, so Q, just now we have 6 times 10 to the power of negative 4 coulombs times 1 electron over 1.602 times 10 to the power of negative 19 coulomb. Alright, so here we just divide the answer with 1.602 exponential negative 19. So we got 3.745 exponential 745 exponential 15 electrons. So now we get the answer. So the number of electron that flow through a light bulb is 3.745 times 10 to the power of 15 electron. Okay, so that's all for the calculation. Thank you.